Hello, thank you, and welcome. Today, I'm going to be talking about Arctic CO2 concentration and climate anomalies. My name is Matt O'Brien. I'm an environmental scientist. Let's go ahead and get started. Okay, so gathering data. Data was gathered from a couple different places around the northern Arctic through the National Centers for Environmental Information, supported by NOAA, or the National Oceanic and Atmospheric Administration. This is an international effort. All the data retrieved in this study, the data is public, but the International Arctic Systems for Observing the Atmosphere is really this system of observatories in different countries, Canada, United States, Russia, Norway, Sweden, Iceland, Greenland, or not Iceland, excuse me, but Greenland. Furthermore, here's a better look at these sites and what the structures and bases or systems actually look like. This one especially, Pallas, has a bunch of you can see the weather instruments or climate instruments on top. Same here. Anyways, one site chosen specifically for this study, Tiksi, Russia, was for its long-standing record of observing temperature. It's 1 to 30 meters above sea level. It's cold, very cold there, as you could imagine. And this is sort of what the temperature anomaly looks like as a whole. You can see that data starts being gathered before 1930 and continues forward to the current day. The red is the high, the blue is the low mean temperature, and the green is the mean temperature. The anomaly, the change in temperature, is 4.47 degrees Celsius. The average temperature for 2020 was negative 8.18 degrees centigrade, and the mean temperature for that whole period of time, the average temperature was negative 12.65 degrees centigrades. So the change in temperature is 4.47, and that is what a temperature anomaly is. Here we're going to break down the years. This is a 15 or 16 year period, 1934, or maybe a little bit earlier, through 1950. It's relatively stable. There's a gap in the data here. And you can see the seasonal variation in the graph to the right. These graphs were created in R. The left, I believe, uses the geom smooth function. So you can see that on the left here on the y-axis that it's -8 through 24, and on the right it's negative or positive 25 through -50 degrees centigrade. That's some of the lows and the highs. So when we take the average for 1935 through 1950, the average temperature was -8.18 degrees centigrade. When we take the average for, or excuse me, 2020's average was -8.18. When we take the average for 1934 to 1950, we get -12 degrees. So the difference there, the anomaly, is 4.47 to 8 degrees centigrade. This is an interesting graph. How stable it is. There's another gap in the data there that we can recognize, possibly due to a war. And I haven't checked the data for a second. It's 2022 and Russia may no longer be providing this data. I have not checked. I do not know, but that's far out of the scope of this video. Anyways, there's a couple of gaps in the data. But the data is still a very accurate record. So we see the data and it's extremely stable. Actually, it's almost completely flat or perpendicular to the x-axis. And again, we see an anomaly, and this time it's 5.35 degrees centigrade, which that's a lot. And really, here we see a culmination of what the point of this video really is. Here in the GeoMSmooth plot, you can see that a rapid rise in temperature, and the anomaly here from 1980 to 2020 is 3.94 degrees centigrade. All right, and then 2021, another anomaly, 3.55 degrees. So the point here is that regional climates are changing across the planet. And I'm really pointing out here that it's much faster in the Arctic, northern Arctic especially, compared to the rest of the globe. And the underlying factor of this is, of course, CO2. And we have some CO2 data that has also been collected in the northern Arctic. The first site is in Alaska, Barrow. And what we see is that it's similar to this temperature graph in the way that it obviously is, the trend is upward. And then another station, so that we can make sure that it's not necessarily a regional increase in CO2, is taking another station in Alert Canada and seeing the same trend. I'll go back to that, let you see it, and point out that this is not a small, like the temperature is a few degrees, which is drastic, but here the CO2 concentration is going from 340 parts per million to 420 plus now. And in 1970, it's down again, 326, 327, all the way up far above 400. So the warming in the Arctic can be attributed to CO2 concentrations rising rapidly. And this is due to anthropogenic emissions, or largely the burning of fossil fuels and other types of emissions of greenhouse gases, such as food systems like raising cattle, etc. So these are my references. You can go gather the data yourselves. It's public data. And thank you for watching this video. If you found it, I'm going to log out as the sun heads out behind these mountains. Thanks.